Today we're going to be talking about analytical trigonometry. First we're going to start with reciprocal identities. Cosecant x is equal to 1 divided by sine x. Secant x is equal to 1 divided by cosine x. And cotangent x is equal to 1 divided by tangent x.
The quotient identities are tangent x equals sine x over cosine x, and cotangent x equals cosine x over sine x. Pythagorean identities are sine squared x plus cosine squared x equals 1, 1 plus tangent squared x equals secant squared x, and 1 plus cotangent squared x equals cosecant squared x.
So our first problem, you have 2 cosine squared x plus sine squared x is equal to cosine squared x plus 1. Use Pythagorean identities. Sine squared x is equal to 1 minus cosine squared x. You have 2 cosine squared x plus 1 minus cosine squared x is equal to cosine squared x plus 1. You combine like terms and you are left with 2 cosine squared x minus cosine squared x is equal to cosine squared x. You finally have cosine squared x plus 1 is equal to cosine squared x plus 1.
On the next problem, cotangent x over cosecant x equals cosine x. What you first want to do is separate the cotangent and cosecant into different fractions. Cotangent x times 1 over cosecant x equals cosine x. Using the quotient identity of cotangent x equals cosine x over sine x, you can turn the problem into cosine x over sine x times sine x equals cosine x. The signs cancel out, turning the problem into cosine x equals cosine x.
For our next problem, we're going to have sine x plus cosine x times cotangent x is equal to cosecant x. First step is to use the quotient identity. Cotangent x is equal to cosine x over sine x. You have sine x over 1 plus cosine x times cosine x over sine x. Now you multiply the sine x over 1 by sine x to create common denominators. Sine squared x plus cosine squared x over sine x is equal to cosecant x. You then use the Pythagorean identities. Sine squared x plus cosine squared x is equal to 1. You're left with 1 over sine x, which is equal to cosecant x. You use the reciprocal identity. Cosecant x is equal to 1 over sine x, and you leave the problem as cosecant x is equal to cosecant x.
The next problem is sine squared x times 1 over cosine x equals sine x times tangent x. You want to separate the sine squared x into 2 sine x values. So it becomes sine x times sine x over cosine x equals sine x times tangent x. Using the quotient identity of sine x over cosine x equals tangent x, you solve the problem and it turns into sine x tangent x equals sine x tangent x.
For our last problem, you have cotangent x plus 1 over cotangent x minus 1 is equal to 1 plus tangent x divided by 1 minus tangent x. You start with reciprocal identity. Cotangent x is equal to 1 over tangent x. You have 1 over tangent x plus 1, all divided by 1 over tangent x minus 1 is equal to 1 plus tangent x over 1 minus tangent x. You then use the identity, the reciprocal identity, to have 1 plus tangent x over tangent x, all divided by 1 minus tangent x over tangent x, equals 1 plus tangent x divided by 1 minus tangent x. The tangent x cancel out one another, leaving you with 1 plus tangent x divided by 1 minus tangent x is equal to 1 plus tangent x divided by 1 minus tangent x. When solving analytical trigonometry equations, always remember to not touch the other side of the equation, and remember your reciprocal, quotient, and Pythagorean identities.
Thank you for watching, and stay classy, San Diego.